Thank you for coming to this year's Doppler radar training. One of the things that I had talked to Colin about was also looping in the outlook changes that went into effect on March 3rd from the Storm Prediction Center, included in one of our trainings this spring because those are super important and a lot has changed with those. So I wanted to include those in here as well. So we're going to go through that. Just a quick agenda for you. I'm going to do an introduction here, and then we're going to dive right into those Storm Prediction Center changes. Hopefully that takes about 20 minutes. One of the things that I will ask is that if you have questions, try to save them towards the end. Write them down, even if we go beyond what is kind of scheduled here. If we go past 9 p.m., I am perfectly free tonight. I can totally hang out with you guys and answer however many questions there are. I'll give you guys my email and phone numbers and whatnot in case you want to get in touch with me privately and ask me a question too. But just try to write those down, maybe hold them till the end because, again, we do have a lot of material to get through. And then after we cover those Storm Prediction Center changes, we will take a look at basic radar, what it is, what kind of the two main products we use on radar are, sort of the history, and just some general reminders. Some of those things will be specific to Kent County Skywarn in particular. So if you are not with Kent County Skywarn, it's not that you can't know the information, but you don't necessarily need the information. It's related to some of our internal policies, but that will only be a slide or so. That will not be a significant part of the training here. So, and then we're going to take a short break. So if you need to use the bathroom or whatever, that would be the time around 7:45. And then after that break, I'd like everyone to be back so we can go into the more advanced side of the training. And then 8:50 to whenever I will do a WeatherWise demonstration and do a QA session again for however long that takes. All right, so with that, let's do an introduction. First of all, thanks to Kent County Skywarn for sort of organizing this. My name is Jonah Drake. For those of you who don't know me, I've been a member of Kent County Skywarn since early 2021. Aside from that, I have more than 8 years of experience as a storm chaser and forecaster, observing all kinds of hazardous weather in our great state here, as well as the many great states that surround us here in Michigan. So I've seen it all: blizzards, tornadoes, ice storms, derechos. I've been there, have been in them, as the case may be, of the Portage tornado. But I'm also the co-founder of West Michigan Weather. For those of you who don't know what that is, we're an organization that provides lots of different weather information. So live storm chasing, forecasts, education, disaster relief, all kinds of different things to a really wide swath of West Michigan. We cover from about US 10 down south to the state line, and then everything west of US 127. So that obviously includes Kenton County, but we include a large portion of lower Michigan in our coverage area. So, all right, so with introductions out of the way, we'll just dive right into the convective outlook updates. So for those of you who don't know, the National Weather Service Storm Prediction Center in Norman issues a suite of forecasts every single day. Most famously, they are known for what you see on your screen here, which are those severe weather outlooks that we're all hopefully familiar with. The SPC also is responsible for issuing tornado watches, severe thunderstorm watches, fire weather outlooks, mesoscale discussions, a host of forecasts and products. But again, most commonly or most notably, they issue these severe weather outlooks. And these outlooks denote thunderstorm and severe weather potential across the continental United States on a 5-tier risk scale. You can see that risk scale there on the image on your screen. from March 31st, 2023, which was a pretty prolific event. So um, there are those 5 levels. So general thunderstorms is the first level. It is not necessarily a severe risk. Um, Technically, there are only 5 severe risks, which is the dark green, the yellow, orange, red, and pink. The light green is not a severe risk. So it's just standard summertime, springtime thunderstorms are possible within a given area. So anywhere on a map that has that light green shading, some regular run-of-the-mill thunderstorms are possible. Not expecting severe weather here, even though sometimes it can occur. It's pretty rare and it's normally weak if it does. We see these risks hundreds of times a year in the spring, summer, and fall here in Michigan. You even see them in the winter sometimes. Moving up from there, you kind of get into the first level of severe potential, the low end of the scale here, with the level 1 out of 5 marginal risk in the dark green and the level 2 out of 5 slight risk in yellow. Those are indicating the risk for isolated to scattered severe thunderstorms wherever that risk area exists. These kind of encompass a low to sort of medium risk for some more isolated damaging wind gusts or large hail, maybe a brief tornado. Once you get to that slight risk, we start to introduce the potential for maybe some low end significant severe weather. So we're talking about maybe a very isolated 75-mile-per-hour wind gust, CF2 tornadoes, something to that effect. But overall, those are kind of the lower ends of the risk. Marginals, we see dozens of times here in Michigan every season. The slice we see several times here, and they, again, can produce some significant severe weather sometimes. Once we get to that level 3 out of 5 risk locally, those are our big severe weather days most of the time here in Michigan. So once we get into that level 3 out of 5 enhanced risk, those are when we see some of our more prolific events here in Michigan. So we're talking May 7th, March 15th, March 30th, May 15th, March 31st of 2023, August of 2023. Any of you who have lived here in Michigan for a while, you know some of the events that I'm referencing there. Those are the events when we see numerous severe thunderstorms move into the area with lots of damaging winds, large hail, and some tornadoes. A few of those storms are significant a lot of the time. And we really only see these risks a few times a year here in Michigan. Anywhere from about 4 to 7 times a year is kind of the average that we see these enhanced risks here. So 4 to 7 days out of the year when we have this enhanced risk in place, those are the days we want to pay attention to. Moderate risk, we get these 1 to 2 times a year or less here in Michigan. When we start to see this red shading, this is where we really start to worry about some more widespread life safety impacts. We're expecting a lot of widespread severe storms. These are going to contain a lot of significant severe weather, more than likely. So lots of strong damaging winds over hurricane force, very large hail, and strong long track tornadoes. Then that high risk, the last one, is very, very rare here in Michigan, thankfully. But if we were to see a high risk, which the last one was in 2013, I believe. So we only see one every few decades here in Michigan. But those are going to be, like, we're forecasting a very intense derecho, like May 31st, 99, or a significant tornado outbreak, which would be quite the feat here in lower Michigan, but certainly possible. Okay, so how do we get to those risk levels? Well, the SPC takes the risk of 3 individual hazards. So it's really, this outlook is really a representation of the hazards that are in place across an area. So it takes the probability of a tornado within 25 miles of a point, the probability of damaging winds within 25 miles of a point, and the probability of large hail within 25 miles of a point. And then kind of the cumulative value is what gives us that 5-tier risk scale: the general, thunderstorm, marginal, slight, enhanced, moderate, high. And then we can talk about significant hazards here a little bit too, but in general, this is the basics. It's the individual probability of any of the three severe hazards in an area kind of give us this final risk. All right, so the old system the SPC uses that three hazard type probabilities: tornado, damaging wind, and hail that we just saw. Like I said, the cumulative value of those three hazards is how we get that 1 to 5 risk scale. One thing I want to note before we go any further is that the criteria and frequency of those existing categorical outlooks, the marginal, slight, enhanced, moderate, high, those are not changing. Those are remaining the same. So that allows us to continue to message those on social media. Broadcast meteorologists can continue to use those. Everyone's kind of familiar with those a little bit. You see dark green on a map. Okay, this is a heads up. You start to see reds or pinks on your map. Okay, this is a big deal. So a slight risk in 2024 will have the same impacts or implications of a slight risk in 2026, and it will have the same frequency. So we'll have just as many slight risks as we did on average in the years past. Very similar to a high risk in 2023 will have the same implications or impacts of a high risk in 2026. Okay, so the system of general thunderstorms, marginal, slight, enhanced, moderate, high, that is not changing. So what is changing? SPC forecasters are currently, or were, because this has actually gone into effect now, we're mathematically limited with the current system, and we're unable to really differentiate between the most likely max intensity of severe weather. In other words, there was no way with that old system to denote a very low end chance for a significant tornado. So like a 2% risk of a EF2 tornado, they couldn't do that. Nor was there a way to denote the difference between a likely maximum EF2 tornado or a likely maximum EF5 tornado, right? When we talk about tornado damage, that's a really, really, really big difference. And they had no way to denote that. Very similarly, there was no way to denote a derecho versus a couple of potential 75-mile-per-hour winds. And this new system fixes that. But it's got some caveats. It can be a little bit confusing. So we wanted to take this time to kind of educate people about that. And so we're including that in this system here, or in this presentation, excuse me. Okay. A couple of things about this new system. Began as a test in the hazardous weather test bed several years ago in 2019. So this has been a long time in the making. SPC forecasters began creating these outlooks behind the scenes in 2021. So as they were distributing the old outlooks, they were doing these new outlooks behind the scenes in private right alongside of those. And they had a lot of success. They were very accurate with them. We'll take a look at some distribution here in a second. But the SPC has proven they can reliably forecast the majority of these conditional intensity group events with a high degree of accuracy and reliability. The new system adds 75 and 90% wind probabilities. So that hazard, that probabilistic hazard risk, was previously capped at 60%. Now they have 75 and 90% wind probabilities as well. It breaks down the old single SIG risk system into a 3-tier, or in the case of large hail, only 2, SIG risk system to better highlight the forecast reasonable maximum intensity of severe weather hazards. Okay, so to sum it all up, there's just now more detailed. The individual hazards and their forecast maximum intensity are much more detailed. So we can still primarily focus on that categorical outlook when we're talking about public messaging. But for those of us who need or want more info, like those of us here on Kent County Skywarn or in this Zoom call, meteorologists, etc., we can get that info, or rather the SPC can get that info to us. All right, so these are the new conditional intensity groups the SPC is using. There are 3 SIG levels, technically 4 if you count 0, but the level 0 will have no hatching on those hazard maps, and I'll showcase that in a minute. But if we don't see hatching on the map, the maximum intensity of a tornado is expected to be EF1. Damaging winds are expected to be less than hurricane force, so 74 miles an hour or less. 2-inch hail or less. And for the day 3 hazards, because they're all kind of combined into one there, we're talking just run-of-the-mill severe thunderstorms. We're not talking about any severe or significant severe hazards. Once we get into that level 1 with the single hatching, it's kind of dashed lines that start at the top right of a risk zone and go to the bottom left. And you can see an example of that there. The max expected tornado would be an EF2. Max expected damaging wind would be around 75 or greater. So at that point, we're talking about the potential for significant damaging winds. And large hail as high as 3.5 inches in diameter. The day 3 would add EF2, EF3 tornadoes, max 90-mile-per-hour winds, or 3.5-inch hail. Again, we have less detailed individual hazard outlooks at that range, so that's why some of those values are higher. Once we get to level 2, this is solid line hatching that it's not dashed anymore, it's solid, and it goes the opposite direction. So this starts at the top left of a risk zone and goes to the bottom right. Once we get into this region, we're talking about intense, strong to maybe even violent tornadoes. So max reasonable tornado strength would be EF3. When we start to look at winds, we're talking about a bow echo or maybe a derecho. So we're talking about a pretty widespread swath of damaging winds with some potential for those gusts to be over 75 miles per hour. And then once we get to large hail, this is the maximum. You'll notice that there is no conditional intensity group 3 for hail. They cap it here at level 2. And that is for hailstones greater than 3.5 inches in diameter. It's really hard to predict hail greater than 3.5 inches in diameter in advance. You really have to be looking at radar, reflectivity, and other tools to predict that. And we can't do that in advance. So they cap it here at the level 2. And that's for hailstones greater than 3.5 inches. Very similarly, for day 3, this is the max it'll go. This is showing potential for tornadoes greater than EF3 strength, 90-mile-per-hour or greater winds, and greater than 3.5-inch hail. Once we get to level 3 with this, what's kind of being dubbed as triple hatching, is these box or this grid shading over an area. For tornadoes, this means that violent or catastrophic tornadoes are possible. So EF4 plus tornadoes or a high-end derecho is likely once we start to talk about damaging wind potential. Again, no large hail or day 3 hazard group here. So that is why that's there. All right. Target reference distribution. So again, we're going to take a look quickly at how the SPC has done over the last several years as I've been testing this. What we really are going to focus on with these graphics are these blue numbers here. Okay, so in general, this is the percentage of tornadoes that occurred. So that's the y-axis. And then on the x-axis, you have the conditional intensity group. So this is that grid shading, this is that solid line, and then this is the dashed hatching. This is, there was no hatching there on the outlook. Okay, so with no hatching, 61% of tornadoes were EF0, 32% were EF1, 6% were EF2, 1% or less were higher than EF2. So that just goes to show how well the SPC did with this over the last 6 years. Over the last 6 years, 1% or less of tornadoes that occurred in the level 0 area were EF3 or greater. When you get into intensity group 1, we start to see 6% of those tornadoes were greater than EF3 strength. So still reasonable. Maximum intensity was pretty good at EF2. 14% of tornadoes were EF2 in that range. And then as we get to intensity group 2, 12% or greater than EF3. Remember, at conditional intensity group 2, we're talking about that potential for more EF3 plus tornadoes. So 12% of them were EF3 plus at that conditional intensity group 2. The biggest thing for me at this level is that the number of weaker tornadoes or the percentage of weaker tornadoes drops pretty significantly. We're down to 36% of tornadoes in this risk zone were only EF0 and 33% were EF1. So when you think about your odds, we're almost split down the thirds. Yeah, you might see a weak tornado, but you could also have just as high of a chance to see a significant or even an intense violent tornado. And then once you get to that level 3 intensity group, 20% or more tornadoes are EF3 plus. So that's a significant number when we're talking about intense to violent tornadoes. Okay, so this again is just showing a breakdown of how the SPC has done over the last 6 years. This is a similar one for wind. Okay, so as we go up, the point is that the number of wind gusts over 65 knots, which is hurricane force, rises increasingly is more prevalent. So it's increasingly more prevalent as you go up in those conditional intensity groups. Again, once you start to get to this conditional intensity group 3, we're anticipating a high end derecho that's usually already ongoing, and 34% of all winds are over that significant damaging wind threshold of 75 miles per hour. And for those of you who have been in an area that has seen 75 mile per hour winds go through, you know the extent of the damage that can do. This is hail, less prevalent in Michigan, but we saw it last night actually, so it's worth discussing briefly. 8% over 2 inches at that level 0, 17% over 2 inches at the conditional intensity group 1, and a quarter of all hailstones are over 2 inches once we get to that conditional intensity group 2. All right. So again, let's take a quick look at these. Some of the changes. Again, these are not changing. This is the categorical outlook, that 1 through 5 scale. These are not changing. We can still share these with the public. You'll see these on the news when we have severe weather threats. This is how we are going to convey, again, that overall cumulative risk to the public. So what is changing? Again, the SPC now has the ability to break down how we get to those risks. So previously, you could not have a 2% with a significant tornado parameter. So you could not say, hey, there's a 2% chance of a tornado, but if one does occur, it might be EF2 or greater. You couldn't do that unless your probability of a tornado was at least 10%. So this new system fixes that. We can have that outlined for those significant EF2 to EF3 tornadoes, even when the probability of a tornado is only 2% or 5%. So this is an example of an outlook the SPC did. We have a large 5% risk there across the northern plains. But they needed to add in that stippling to indicate that there was a chance for an EF2 tornado in that risk area. The old system would not allow them to do that. You see here there's 5%, but there is no 5% with significant severe underneath of it. This new system fixes that and allows them to add in that conditional intensity group 1 at that 5% level. Very similarly, this is from March 15th of last year. This is what the old outlook looked like. You see, we don't see the introduction of that significant parameter until you have the probability increased to 10%. You'll notice there is no hatching in the green or 5%, or in the green or brown there. And there's also no indication that of the strength of the given significant tornadoes in this area. So the new system fixes that. We see the conditional intensity group 1 extending well into those 2% and 5% regions. We see the double hatching, indicating the potential for an EF3 plus tornado. And we even see that triple hatching in the area of the risk where they believed that the greatest potential for a violent tornado to occur. And at least 2 violent tornadoes did occur within that conditional intensity group 3 grid shading there in parts of the Gulf Coast. Okay, so similarly with wind, this is the old system. We don't see the hatching start until we get into this red 30% region. We do have a 45% region outlined there. And this is that new system, so it allows the significant shading to extend beyond. And we see the introduction of the 75 and 90% wind probabilities on the scale here, even though for this particular outlook, they were not used. Right, and then for hail, this is what the old outlook looked like. And then not very many changes there with this particular outlook, but that's just an example of what the new conditional intensity groups might look like for hail. For day 3, I don't have a map, but we can use this as well for our conversions to our categorical risk. So before, we could only go up to 45% with significant severe, and that was giving us a level 4 moderate risk. Now we really have to have a pretty significant high and severe weather event forecasted to get up to that moderate. And they're trying to reduce the amount of false alarms with this stuff. So this is a really good revision for that day 3 outlook. Okay, so just to quickly wrap up, this new system is designed to visually indicate where the highest likelihood of the most intense bouts of severe weather hazards are expected. It eliminates those limitations they had on the low probability but high impact events, and allows for the discrimination between significant, destructive, and catastrophic event potential. So are we talking about an EF2 tornado, or are we talking about an EF5 tornado? 60, 75, and 90% probabilities for wind and 60% probabilities for tornadoes will still be fairly rare, but they do have those options now. Conditional intensity group 3 delineations, especially for damaging winds, will be exceptionally rare and will often only be issued as an event is ongoing. So once derecho is ongoing, like if we've got a derecho in Wisconsin, Michigan might be upgraded to that conditional intensity group 3 for wind, but it'll be exceptionally rare. And then these groups will or should correlate fairly well to the max intensity indicators on the SPC mesoscale discussions that are issued before severe thunderstorm and tornado watches come out. So it's a good way to kind of compare and contrast those, get a really good sense of what the SPC is thinking for the worst case scenario, essentially. And so while the frequency of higher probabilistic hazards is really expected to increase, so we might see more 5% tornado risks this year than we have in the past, more 10% tornado risks this year than we have in the past. They have reworked it so that there are no changes to the implications of that to the categorical outlooks. And then for those of you who are familiar with the day 4 through 8 outlooks, there are no changes to those. Right? So basic radar training, we're doing pretty good on time here. That took about 5 minutes longer than I was hoping, but that's okay. We'll do basic radar training here, and then we'll take a short break. So background and history of Doppler radar. Doppler radar uses electromagnetic energy to reflect signals back to its source. So the radar beam shoots out or the radar dish rather, shoots out a beam of energy, and that is reflected off hydrometers, rain, hail, snow, or in some cases, debris or biological objects back to its source. And then the computer at the source converts that data into something we can analyze online using our computers, or even on your phone. This technology was discovered by physicist Henrik Hertz, pardon my German there, in 1886. We used it in 1904 to aid in marine navigation, and it really became popular in World War I and World War II when soldiers watching for enemy planes discovered that they could also detect rain and snow. So, knowing that we can detect rain and snow with this radar, the Department of Defense and the Department of Commerce, in cooperation with the Department of Transportation, kind of resulted in the inception of NEXRAD, or what is known as Next Generation Radar. And that is what is primarily used in our WSR 88D model weather radars. This current network of WSR 88Ds is used across the country by the National Weather Service and are the same radars that we, with this proper training, can use to positively change the way we conduct our operations here at Kent County Skywarn, and is a great way for you, even if you're not part of Kent County Skywarn or a local Skywarn team, to be more weather aware, to have an understanding about what might be heading towards your location at any given time. So how can we use Doppler radar then? We can use Doppler radar to sort of peel back the curtain and really take a really close look at the inside of storms, what is happening inside of that cloud. So we can take a closer look and identify rain, snow, and hail, see in which direction and how fast those things are moving, and identify areas of interest in a storm or storm complex. So we're talking about hook echoes, debris balls, all of those kinds of things. And those things help us determine whether or not a storm poses an imminent threat to our area and of what severity that threat may be if it does indeed exist. Right, so there's just an image kind of what the weather surveillance Doppler radar, those WSR 88Ds do. Again, we see these beams of energy, going out into the supercell or whatever we happen to be looking at, and then those are reflected back to the radar. Right, so very quickly, I just want to go over a few Skywarn specific policies for Kent County Skywarn. Again, if you are not on Kent County Skywarn, you don't need to memorize these or anything. It's just for our team members. We wanted to cover these quickly. Net restrictions. So if we're in a severe weather net or a winter weather net, these are some of the restrictions. If we're on command and control, we welcome radar updates from around the Great Lakes region. So if something's happening in Iowa or Wisconsin or Illinois, we are encouraged to share those things with everyone for situational awareness. Once we move into a net, so if we're green, radar updates from around the state that you reasonably believe could or will impact Kent County. Again, those are acceptable. We want you to share those things, but just use a little bit of discretion with the amount of radar updates that you're providing. If you're seeing something in Iowa that's not going to be in Michigan for another 5 hours and there's something more imminent, probably not needing to share that. Once we go to yellow and we're taking check-ins, only break into the net with radar updates if you believe that radar update would necessitate an upgrade to a red bone net. So if you're seeing some kind of severe criteria or you're seeing indications of a tornado on the ground, then that would be something you could maybe break into the net with. Once we go to red, we're only looking for occasional and very important updates concerning radar. So really we're looking for life-threatening things that we're seeing on radar, or very periodic situational awareness updates. A lot of the times those should come from net control, But red nets, again, should focus on those open channels for storm reports and getting warning updates into the net. And then if we're doing a snowfall net, we don't really need radar reports. And then very quickly, if you have a radar update and need to provide it to the team in a net, use the pro word radar to break into the net with your call sign. So for me, example, if I was going to give a radar update, I would say net control KE8 ULI radar, and then wait for net control to acknowledge me. For more impactful radar updates, again, like if you're seeing debris balls or destructive winds, it is acceptable to maybe add an additional pro word in there, like urgent or emergency, when breaking into the net. So if I saw a swath of destructive winds moving off of Lake Michigan heading our way, I might break in and say urgent, net control K8 ULI urgent radar, and that lets net control know that I have some kind of urgent radar update that concerns Kent County on a pretty high level. Right. Treat radar updates like you would a storm report. So if you're going to give a radar update, say the time, what is the event? Is it a debris ball? Is it destructive winds? What is it that you're seeing? And the location of what you're seeing, if you possibly can. Again, if you aren't sure of what you're seeing or you don't know, it's inconclusive, please say that. Please acknowledge that. Report only what you know. Don't guess. Don't assume. Accuracy and precision are paramount with these things. And again, these are public nets. We're on open channels on the amateur radio repeaters. We're not on 800 trunked private radio frequencies like police and fire are. Anyone can hear this. So if we're throwing the term tornado signature on radar out on those open nets, and it's not really one, we're creating undue panic. So only do so if you're absolutely sure about something. Okay. With that out of the way, just some important reminders about radar. Take this from you with a host of experience. I have learned this the hard way, I'll say. I've learned these things the hard way. Like any technology, Doppler radar, A, has its limitations, and B, it is not infallible, okay? That radar beam only rotates and scans each part of the storm around every 2 to 5 minutes. And a lot can happen during those gaps between those radar sweeps. In fact, most Michigan tornadoes are on the ground for less than 5 minutes. So if the radar is only scanning a part of a storm every 2 to 5 minutes, and most tornadoes are only on the ground for less than 5 minutes, it may miss that tornado entirely. So if you're at your house or you're out storm chasing and your radar isn't updating, or it misses that, like it just scanned and then it drops a tornado, it may not see it. So always bear those things in mind. Radar can't see everywhere. Radar holes, ground clutter, and the curvature of the earth must always be considered. Technical glitches and utility outages, so power, internet, all kinds of different things can either on your end or at the site of the radar itself could result in that data being delayed or unavailable. And then the biggest thing is do not rely on radar to keep you safe while you're observing that hazardous weather. Again, it is not infallible. All right. So let's talk about some of those limitations. The Earth's curvature is a big one. Because the Earth is curved, right? I promise you the Earth is not flat. Because the Earth is curved, we have to remember that as that radar beam goes out in a flat line, right? We see the radar beam here as it goes out. It is scanning higher and higher up in that storm. It really is important that we remember that something several miles away from the radar may not necessarily be right at the surface of the Earth. So this can result in difficulty determining if decape, which is downdraft cape, not something you necessarily need to know for this, but if we don't have strong enough decape to make severe winds at 8,000 feet down to the surface, then they probably aren't getting down there, even though radar is showing those severe winds. It can result in difficulty determining if a tornado is in fact on the ground with a strong velocity couplet at 5,000 feet. So if we don't have surface-based storms and the radar is showing a strong velocity couplet at 5,000 feet like it was last night, that tornado is likely not on the ground unless we have surface-based storms. So it's important to remember that stuff when we're observing radar. In general terms, the farther away from the radar a storm is, the higher up into that storm the radar is scanning. Okay, so we can see here, thankfully, we've got a lot of radars across the country, but we do have these gaps. These white areas are radar gaps across the country where those areas do not see or have no radar coverage. So they could not see a storm in this area if there was one there. So again, despite the 160 radars, there are not enough to cover every square mile right down to the surface, or even as high as 10,000 feet off the ground. Okay, again, so we see the pale yellow is we've got really good radar coverage, 4,000 feet above ground level or less. The orange is 6,000 feet above ground level or less. And the blue is 10,000 feet above ground level or less. So these radar holes can make it increasingly difficult to see the features of a storm on radar in portions of the U.S., especially west of the Mississippi River, and just in other areas of the U.S. that are kind of farther away from a radar site. So here in the Carolinas, maybe it might be harder to see a storm there. So it's just important to remember that not everywhere can have really good radar coverage. Thankfully, here in Kent County and really in West Michigan in general, we have pretty good radar coverage. We can see very close to the ground, especially here in Kent County, because the radar is actually in Kent County. So really, we start to see that drop off along US 10 here in the far northwest portion of the National Weather Service Grand Rapids coverage area. So once we get into that area, we're only looking at a max, or at a minimum, excuse me, of 6,000 feet off the ground. So that storm, whatever we're looking at, that data is at least 6,000 feet up into that storm. So we have no way of knowing what's happening at the ground. Radar signatures are increasingly difficult to rely on once they are above 4,000 feet. And they become very unreliable above 10,000 feet. All right. Give me 2 seconds here. Thankfully, locally, we have that very good coverage on our radars, as I was saying. The exception to this can be in the case when a storm, especially a potentially tornadic storm, is in very close proximity to the radar site. So here we see the radar site, which is at the Gerald R. Ford Airport in Kentwood. And we see this area of rotation here on radar. And we'll talk about this, how to determine what is rotation here in a little bit, but we see this area of rotation here, and it's very close to the Doppler radar site. And we see that it's kind of contaminated. We have these gaps here, we've got a gap here. It looks a little bit wonky. So it's important to remember that we have really good radar coverage here, but once it gets so close to the radar, it may actually be missing what's happening at the ground. So if we've got a tornado on the ground, the radar pedestal itself might be causing the radar beam to shoot over what is happening at the ground there when it's so close. Some recent research suggests that tornadoes may begin from the ground up. So we may be looking at a storm that has rotation, and there's actually a tornado on the ground, but the rotation is questionable at 3,000 feet because the tornado has started at the ground up, or at the ground rather than from the cloud down to the ground. So it's just important to remember some of those things. So let's talk about range folding now. One of the other limitations to these systems is what's known as range folding. So there are limits to the scales that these computer algorithms have. And this creates an effect, again, known as range folding. We most commonly see this in velocity. This is a picture of the Midwest cereal derecho from August 10th, 2020, that impacted parts of Iowa, really a large swath of the Midwest, but parts of Iowa were severely impacted. And so here's the radar site. We see winds out here to its west, moving towards it. Again, green winds are inbound winds. So these are moving towards the radar. These green winds are moving towards the radar. Reds are winds moving away from the radar most of the time. However, in this case, all the colors we see here, the reds and the greens, are actually moving towards the radar. So what has happened is the winds are so strong. We start at 0 miles per hour, and they have gone up, hit this 70 knot mark, gone back on itself, gone all the way down, and started to come back into this green scale again. So it has folded over on itself twice. Okay. So this is indicative of winds over 140 knots, which is about 160 miles per hour, which is just insane to think about. But that was a great Midwest cereal derecho, and that's a perfect classic case of range folding. Ground clutter, artifacts, and obstructions. For us here locally, one disadvantage we do have for about 20% of our area here in Kent County is this radar artifact. It bisects much of northwest and west central Kent County, extending northwest from the radar beam's origin point here at the airport, all the way through Comstock Park, through Sparta, west of Kent City, and then it eventually continues off towards the lakeshore. But we can see what impact it has here. It is not realistic to believe that there is a perfect bridge or a perfect valley, perfect gap between this line of very strong storms, very heavy rainfall that was moving through the area on this given day. And this is because there is actually a building, or I think maybe it's a water tower that sits in very close proximity to the radar. And the radar beam actually hits it and it scatters it or prevents it from continuing out. And that creates this sort of gap here. So if we have a velocity signature or we're looking at hail potential, and it happens to be in this zone of this radar artifact, it's important to take it with a grain of salt, really consider what is actually happening there. And again, that's where spotters come in a lot of the time. So we have a really important job in providing ground truth, especially in areas like this. All right, so ground clutter, buildings, birds, dust, trees, fog, can kind of give the appearance of light rain or light snow at times on radar. This is known as ground clutter. So we see it when it is, overnight into those early morning hours when radar is, excuse me, when radar is more likely to pick up those non-weather related objects. All right, software. There's lots of different options. There was already a question about GR level 3 in the chat. Some of you may be familiar with Radar Scope, Radar Omega, My Radar. Your local TV station has radar on their app. WeatherWise is a big one. Quad Weather, Weatherfront. So what should you use? I really recommend WeatherWise, though each platform offers a variety of features at varying prices. In my opinion, WeatherWise is quickly becoming the leader in this market. For no charge, base products including NWS alerts, outlooks, reflectivity, velocity, and more are available online. So you can use a browser software, or you can get your app on the app for your mobile devices. Additional charges unlock national satellite weather models, yada, yada. But the thing that sets this apart is that stuff is available for free on browser and on an app, again, for free, whereas Radar Scope, Radar Omega, there is some kind of upfront cost. GR Level 3, there's an upfront cost to getting those products. I think I covered all of that. If you're storm chasing, if you're doing Skywarn ops, try to have two different radar platforms available to you. Don't rely on one. Again, they're not infallible. Yeah, I think that covers that pretty well. Single site radar versus MRMS. Okay. MRMS just stands for multi-radar, multi-sensor. Has many of the same features as single site radar, but in fact combines those products or the products of all the single site radars across the country into what we call a composite. So this results in a very similar but much lower resolution look at the output of those single site radars. So it's a good tool for overall situational awareness, looking at kind of a broad scale picture of the area. I have one that sits up here above my desk that is just constantly looping with the latest data. I have it up all year round that I use to just kind of build my situational awareness, but it is not a good tool to use for storm chasing, for red mode Skywarn operations, because it does not rapidly refresh and it does not provide that high resolution pixel by pixel data that we need. So my radar, WZZM13, Fox 17, all of those apps use composite MRMS radar, and it is not a reliable tool to use for storm chasing or Skywarn ops. This is what that might look like. So this is MRMS radar. Here's a little bit zoomed in picture of a composite view near Elizabethtown, Kentucky. And here's that same system in that high resolution single site rapid refresh radar. We can see how much more detail there is between those here. Okay, so that's important, why it's important to have single site radar available to you. Single site radar is a primary tool utilized to observe near surface atmospheric weather behavior and precipitation. Again, there's 160 of those data across the US and our territories. We primarily rely on the site here in Grand Rapids, but we can also use other sites if Grand Rapids happens to be down, or if we're looking for comparison or correlation between something that Grand Rapids radar might be seeing. So there's the Milwaukee radar site in Wisconsin, the Northern Indiana site in far Northern Indiana, the Chicago radar site on the other side of Lake Michigan, the Gaylord radar site to our north, and the Detroit radar site to our east. There are two main products we utilize when we're using single site radar. The first is reflectivity, and the second is velocity. Reflectivity shows us the position, size, and intensity of those hydrometers. So hydrometers are rain, hail, or snow, and velocity shows us the speed and direction at which those hydrometers are moving relative to the radar site. So this is a radar reflectivity. On a standard color table, cooler colors, gray, blues, and greens, show lighter, smaller, and or less dense hydrometers, while warmer colors, reds, pinks, and whites, show heavier, larger, and or more dense hydrometers. These colors directly correlate to the unit of measurement that reflectivity shows, which is decibels of reflectivity, or dBz. Okay, and then I kind of have the scale there. So at gray, we're talking about grunt, clutter, fog, steam, maybe some insects or birds. Blue is very light rain, freezing rain, or light snow. Once we start to see green, we're talking about light rain. Yellow, light to moderate rain. Orange, moderate rain. Reds and pinks, heavy rain, maybe some small hail. White, we're talking about very heavy rainfall and small to large hail. And then once we start to see that transition to dark gray or black or violet, we're talking about large to very large hail. Anything over 80 dBz is maybe say giant hail, so in excess of 3 inches. Okay, but we'll talk about some of those key visual signatures here in a little bit. The second product we use is radar velocity. Standard settings, your radar will show the speed of hydrometers probably in knots. I recommend changing this in your software settings to miles per hour. It's kind of the unit of measurement we're all familiar with here in the US. If you're a weather nerd, you kind of know the knot conversion off the top of your head, but just set it to miles per hour. It's easier. The brighter the colors, the higher the wind speeds. So reds indicate winds moving away from a radar site, and greens indicate winds moving towards the radar. So we see two scales here. This is the red moving away from the radar. So as that color gets brighter, we see increasing winds. Very similarly, the greens showing radar winds moving towards the radar get increasingly faster the brighter the color is. It's important to note inbound velocities, so these green colors are shown as negative values, but you can just kind of negate that, negate the negative sign. So if you see a negative 73 mile per hour wind velocity, just say it's 73 miles per hour. Yeah. Again, it's important to consider the elevation at which the radar is indicating the wind speeds. So wind speeds of 70 miles per hour at 8,000 feet probably only correlate to less than 40 mile per hour winds at the surface, except in extreme cases where we have very high decape. And again, we'll take a look at some signatures here later in the training. All right, so we are on break now. Please be back in 5 minutes. It's almost 8 o'clock, so we'll say 8:05. Be back. Well, it is 8:05, so I'm going to continue on with our training here. We're going to get into the advanced radar training part of this presentation. Again, if we run a little bit over 9 o'clock, I am totally free to hang out here in the Zoom call and answer questions, and I'll also be providing my email and website address for those who maybe want to have a more private or in-depth conversation, but I will be here. Just trying to get my PowerPoint to continue on. Here we go. Alrighty, so we're getting into the advanced radar training. We'll take a look at some more common radar signatures using the products we just described. Some of the things that maybe are a little bit more familiar, but take a trained eye to interpret correctly. Okay, so perhaps the most common one is the hook echo. And this is a common characteristic on supercellular storms, but can also appear on multi-cell storms and linear complexes as well. And what this is indicative of is RFD winds, which is rear flank downdraft part of the storm, winds wrapping around the mesocyclone, which would be the area of concern for a tornadic thunderstorm. So the mesocyclone is the rotating updraft part of the thunderstorm. This does not always indicate the presence of a tornado, but can be a good clue, especially when it's well defined, like we see here on our example here. Okay. Again, we see this kind of fish hook shape, this hook echo shape on many of the supercells that are in this radar mosaic here. But this is also a hook echo. So this is not that cellular shape that we saw previously. This is our more conglomeration or linear storm mode, but we can still see here that there is a fishhook shape here. in the area I've circled. Okay, so in 3D, let's kind of break down the part of the storm we were just looking at. So this is the mesocyclone, the rotating area of the thunderstorm. This is that rotating updraft. This is the rear flank downdraft. So this is an area of very, very strong winds carrying precipitation. Most of the time rain, but you can get some hail thrown in here too. And it's being carried by these very strong rear flank downdraft winds. And then it is wrapped back up by the storm's inflow. And we get this real fishhook sink drain type effect. In a very pronounced hook echo, you can see an area of higher reflectivity. So we see the tip of the hook here go from red to dark red to pink. That would be an indication of debris actually being lofted into the air. Okay, so looking at that in 3D, we can see the large supercell here, the rotating mesocyclone, and we have the RFD surging behind and then wrapping back up on itself in the hook echo, and right in the center of the hook echo, we can see the actual tornado that was on the ground with this particular supercell. Again, a hook echo does not always guarantee the presence of a tornado, but it can be a really good clue, especially when you see the debris ball here on the base of the fish hook. So we talked about hook echo. Let's talk about what a bow echo is. And a bow echo is a more common characteristic on linear storm complexes, including metoscale convective systems and derechos. And this bow echo is indicative of very strong winds forcing precipitation out in front of those driving wind fields. Okay, so we see how our storm begins here. It expands and kind of takes on a slightly more curved shape as the winds kind of push into it. As those winds continue, we see that bow become even more pronounced. And this is kind of a 3D view of that. Okay, so we have very strong outflow winds surging out ahead and really pushing that very often destructive wind field out ahead of it. So again, it's indicative of very strong winds driving that precipitation out in front of those wind fields. This signature can be a clue in the right environment that considerable and even destructive winds, 70 to 90 miles per hour, are mixing down to the surface. And we have to watch the head and the tail of these signatures, especially on more well-defined comma echoes, which is what this is. We can see it's kind of got the shape of a comma for what we call bookend vortices. These bookend vortices are tornadoes that form because we actually have rotating wind fields in this area here of the comma head. So a lot of the times you will get a tornado to spin up kind of in almost that hook echo area. It's kind of like a little mini supercell attached to the top of this Boeing segment. And you will a lot of the times get, not a lot of the times, but sometimes you can get those spin up tornadoes on those bookend vortexes. Okay, so this is an example of what that might look like on reflectivity. We can see this very well pronounced bow shape to the storm here. Okay, very similarly, this is from May 31st. I think I have that date right. May 30 and May 31st of 1999. As that very intense derecho moved into West Michigan. We saw some winds in West Michigan estimated at 130 miles per hour or more from this storm. All right, so that is a bow echo or a comma echo. Let's talk about three-body scattering spikes, or more commonly known as TBS. And TBS are a signature that sometimes can emulate from a thunderstorm that contains large to very large hail. And this is characterized when a storm has a strong reflectivity core. So we're talking about pinks, whites, purples, violets, in terms of the colors that you're seeing. So we see an area of whites, pinks, and violets here on this particular storm. And then a lower echo spike that kind of emulates out from the storm parallel to the radar beam. So our radar site is down here in this particular image. And we see that as that radar beam travels, it's hitting this storm here. It's analyzing all this precipitation, this very heavy rain and hail core here. And then there's this little spike that juts out from it. That is indicative of that large to very large hail potential that was ongoing with this particular thunderstorm. We can also see in very rare cases that three-body scattering spike emulate from debris balls. When we have a tornado, often a strong tornado on the ground, and you see there's a very intense reflectivity ball there from all the debris that the Mayfield tornado was lofting into the air after it hit Mayfield, Kentucky, that we actually get a very similar type of effect. So the radar beam is located, the radar site is located up here off screen, hit that very strong area of reflectivity, and created that three-body scattering spike. So that can be another clue that we have a tornado on the ground in some very rare cases as well. BWER, or a bounded weak echo region, is a signature that appears often on supercellular thunderstorms, but can appear on other types of storms as well. But it's most common in supercellular storms and is indicative of a really strong updraft, which is sort of flunting the precipitation out away from the rotating area of the thunderstorm, out of the updraft region, and towards the forward flank of that thunderstorm. So the forward flank would be out here, and the updraft is located back here on the south side of Norman. And it is the updraft is causing all the precipitation to be flung out into the forward part of the storm, and it creates this kind of hole here known as a weak echo region. So the echoes that the radar is getting back are weaker here because there is less precipitation here, hence the name weak echo region. And it is bounded by areas of higher reflectivity. It's indicative of some of the largest hailstones and can be a clue of how supportive a storm's updraft may be able to support the longevity of a severe threat and tornado risk. So here's another example of that. Really clear bounded weak echo region there in the rotating part of the supercell thunderstorm near Jonesboro, Arkansas. All right, so those are some of our reflectivity signatures that we look for when we're observing radar. Looking at velocity, which is again showing the speed and direction of winds relative to the radar, we can also get some clues from the signatures we see with this product as well. The first is a velocity couplet. And a velocity couplet is when inbound and outbound winds exist in very close proximity to each other. Okay, so again, reds are those winds moving away from the radar, and greens are winds moving towards the radar. And when those exist in very close proximity to each other, that is a velocity couplet. I will say this is one of the most easily misidentified signatures on radar. It is very easy to confuse convergence, divergence, all kinds of different things, radar contamination with a velocity couplet. So you really have to consider all the factors, all of the products when you're identifying a velocity couplet. does this couplet make sense for where it's at? Is it in the right part of the storm for a velocity couplet to exist? So if we're looking at a supercell, and this particular couplet happens to be where the hook echo is located, that's probably a pretty clear indication that that is a tornadic velocity couplet. If it's located on the forward flank of that supercell, it's maybe just an indication of some surging winds, some higher winds, gustier winds. Maybe there's an anticyclonic tornado or something there, but for the most part, we really have to use these tools. Again, this is one of the most easily misidentified signatures on radar, and the NWS gets a lot of phone calls and pings on Twitter and etc. of people sending in screenshots of radar, which they can see, by the way. They don't need you to call them to tell them about the radar. I promise you someone is watching it. But they're saying there's a tornado with this velocity couplet when it's really not even a velocity couplet. So just be sure before you're identifying things as velocity couplets, make sure it makes sense with the position of the storm. Right, so we see a couple examples of velocity couplets here. And again, we talked about making sure it makes sense with the storm mode and what we're talking about. So this is a mesoscale convective system, and we see the area of reflectivity here, and we've got that little notch, that little hook echo here in the kind of the center frame of this particular radar screenshot. And it also has a velocity couplet associated with it, maybe even two velocity couplets associated with it. And so that makes sense. It's in the area of the storm that we would expect to see that velocity couplet. So we can pretty reliably say that, yeah, there's maybe a tornado threat with this. Okay. A tornado vortex signature, or known as a TVS, a tornado vortex signature, is a velocity signature that indicates the presence of tornadic circulation specifically, consistently through at least the two lowest levels of elevation tilts on the radar. So it has to be on tilt 1 and tilt 2 for it to be considered a tornado vortex signature. Again, it does not always mean that there's a tornado on the ground, but when we start to see really clear couplets like this on multiple tilts, multiple elevations of the radar beam, we can our confidence in the fact that there probably is a tornado on the ground increases. And this is, of course, a velocity couplet from the catastrophic Moore, Oklahoma tornado. Rear inflow jet is something we look for in those Boeing segments on those bow echoes and comma echoes, and it shows a surging and intensification of destructive winds moving into the bow echo region or gust front region of a linear storm complex. Again, those bow echoes, derechos, and can be an indication of a serial derecho reaching its peak intensity when we start to see this signature. It's important to note that when this signature is present, we often have swaths of destructive level damage. So that's 80-mile-per-hour winds or greater, ongoing in the path of this rear inflow jet. So this is from a couple summers ago. Thankfully, Kent County was spared from a lot of the impacts, but the Muskegon area got decimated with these winds. And we can see that there are an indication of very, very strong velocities here in the rear of that gust front. So if we imagine our comma echo is right along the gust front here, that's where our reflectivity would be. And kind of behind it, behind that bow, we see that inflow, that very intense inflow jetting into that gust front. And that particular rear inflow jet was measuring up to 115 miles per hour. So very, very strong winds. relatively close to the surface, 3,000 to 8,000 feet off the surface. Okay. Again, when we see these instances, like we did back on May 30th and 31st in 1999, in the presence of those very strong rear inflow jets, we can see those winds mix down to the surface very, very easily and cause very significant damage. Right. So this is actually the same serial derecho, the Midwest serial derecho, uh, from a few years ago, and we can see another example of that. We see a very strong rear inflow jet here, measuring over 130 miles per hour in some places there. So those are some of the signatures we look at for reflectivity and velocity. There are a couple of other products. May 31st, 1998. Thank you, Kevin. I appreciate it. That's when that derecho was hit Michigan. I kept saying 99. I apologize. There are some other products from the tool polarization system that these radars have that we can use to our advantage. And so dual polarization means that the radar beam comes out in two different polarities. We've got the horizontal polarity and the vertical polarity. So you can kind of think about it in a sense of there's two different beams. And the two different beams going out in different orientations can kind of give us a 3D picture of what's happening in the storm. The most common product that comes from this is correlation coefficient, or what's commonly known as CC, in very simple terms, is the comparison of the various different objects and hydrometers that the radar beam is reflecting off of. So it's sending that radar beam off out into the storm, and as that radar beam hits rain, hail, whatever's in that storm, it's comparing it to each other. So how similar are those raindrops to the other raindrops around it? The more similar the objects are, the value will come back to the computer software as closer to 1. And the more different those objects are, the CC will be lower with values closer to 0. Correlation coefficient can help us identify different precipitation types when we're talking about winter weather. So the difference between freezing rain and snow. It can help us detect hail, and it can most commonly be used to detect and confirm tornadoes on the ground. There's just a little example. Again, as we see those products or those hydrometers that are more similar, we'll see those values closer to 1. And then as we start to change those, we start to see those values drop off. And once we get down here to debris, tornado debris, obviously you're going to have a lot of different size particles being lofted into the air. We're talking about 2x4s, trees, shingles, entire houses, entire vehicles, in some extreme cases. So your particle size is going to be vastly different. And we see what's known as a CC drop, or what's known as a tornado debris signature or debris ball. And this is a small pocket of lowered correlation of the hydrometers coexistent with that rotational velocity signature. So again, it's important to use all of our radar products to kind of correlate these things to make sure that it makes sense with what's happening. So if we see a debris ball and the ball was actually up here instead of in line with this rotational signature, that might be more of an indication of a hail core rather than a tornado. But when these two line up, as these two circled areas do, we can pretty much confirm that there is a tornado on the ground. And in this particular image, there was an intense tornado on the ground with this. There was an EF3 tornado on the ground with this particular signature. And so these signatures are often how tornado warnings are upgraded from radar confirmed, or I'm sorry, radar indicated to radar confirmed tornado warnings. So if you ever get a tornado warning on your phone and it says the source is radar confirmed, that is because we are seeing these debris balls more often than not. Right? Differential reflectivity is another product we can use. This is known as ZDR, and it helps to identify the ratio of horizontally and vertically polarized hydrometers or other objects. Most commonly used to help identify hail cores, but it can be used to refine precipitation rates, find updrafts and thunderstorms, and it can also be used to help confirm tornado debris. So anything that has a high ZDR, we're really thinking about rain. A low ZDR is light rain or hail. And then once we start to see those values dip below zero, we're talking maybe there might be some tornado debris in there, depending on if it makes sense with the other products that we're seeing. Okay, so this is, of course, from the El Reno tornado on May 31st of 2013, and we see that very, very, very high ZDR there. I'm sorry, the very low ZDR there showing that hail and tornado debris. Okay. There is also a ZDR ring. A ZDR ring is an indicator of a very mature supercell. Again, this is from the El Reno, Oklahoma tornado of May 31st, 2013, which is a very, very strong supercell, very mature supercell that had a very strong updraft. And that's often in close proximity to that B word, the bounded weak echo region that we were talking about earlier. And that indicates that that updraft is lofting those melting hydrometers, and then those hydrometers are pushed out counterclockwise by that mesocyclone. So when we start to see this ring shape, when we're looking at differential reflectivity, it can be a sign of a very, very strong updraft. Again, until you start to see supercells like the El Reno tornado, you don't see this very often, but it is good to know nonetheless. Vertically integrated liquid is used to determine an estimate of the total mass of liquid water within a single vertical column of the atmosphere. This is most commonly used to identify hail cores. So you'll often see this product referred to as hail tracker. The higher VIL values, especially when correlated to high VIL density values, can be indicative of a hail core with very large hail. We saw a lot of these work through our region yesterday as we had those large hailstones move into the area. This can also be used to identify microburst potential. So microburst is when a storm essentially collapses on itself and it results in a surge of very strong, considerable to sometimes even destructive, damaging winds surging out as that storm collapses on itself and becomes outflow dominant. And that is indicative of a rapid decrease in these VIL values. So if you see a storm with a really high VIL, like we do here, and then a few scans later, this scan is all those colors are suddenly gone in an instant. That can be an indication that, hey, maybe there was a microburst in that area. I wouldn't be surprised if you looked at velocity and saw a couple of pretty strong velocity signatures there. So echo tops is another parameter we can use. This basically just shows how tall those cloud tops are, or the updraft peak of a thunderstorm is. And so that is hence the name echo top. So it's the echo of the radar beam and how tall that echo is. This is really helpful in determining thunderstorm maturity and overall intensity, as well as hail potential. So as the warmer colors start to make their way onto the screen here, those are very tall thunderstorms with potential for a persistent updraft, some hail potential, maybe some mesocyclonic rotation potential. Overall, just a very mature thunderstorm. Whereas some of these cooler values, the greens and blues, show maybe some rain showers, some less mature convection. Right. So we are doing really good on time here. So we will do the WeatherWise demo. And then I will take questions and we can go back to any slide on this presentation. We can talk about WeatherWise. We can talk about other radar platforms, whatever you guys have questions about. So this is WeatherWise. This, again, is the software that I recommend using. There is a lot of different customization that you can use with this. I pay for Pro, which gives me access to all the features. So I have models and satellite data, but those are not strictly necessary. Again, for free, you get single site radar, National Weather Service outlooks, so we can see our severe weather outlook for today. With that very large slight risk in place. There are a lot of different map customizations. So I can make it a dark theme. I can make it light. You can use their default settings. It's just lots of different customization features. Unfortunately, we don't really have any. There is one tornado warning on ongoing, so maybe we'll take a look at that and see if there's any of the signatures we just talked about that we can see. Okay. And this right here, let me grab my draw tool. This area right there is what they're going to be concerned about for the tornado potential. I would expect that they would continue that here shortly, extend that warning. But we can see the tornado watches, the severe thunderstorm watches, has all the alerts. We've got high wind warnings out here to our west, winter storm warnings, blizzard warnings. Again, I pay for Pro, so I have satellite and models, so I can look at the snow that is going to be possibly impacting us next week. I know, sucks. Very sorry. Let me see if I can get my audio working here so I can start to take some questions. But overall, just a really good program to have. It is what we use at West Michigan Weather for all of our live streams. Again, this is free and you get access to single site radar, totally free. And you can use that online on your browser, or you can download the app for it on your phone. You cannot, unfortunately, use the desktop application until you pay for it, but you can, of course, use Google Chrome to view it, or Internet Explorer, or Microsoft Edge, whatever you happen to use. And I'm trying to just make sure that I can hear you guys. I'm not sure why I cannot. Ready. So we do see, we look at our winter weather radar. we do see snow moving into our area. We could zoom in on these flood warnings. Just trying to show off some of the different features while I try to fix my audio here. I know I'm kind of back and forth here, folks. Colin, if you have anything that you want to talk about while I try to fix my audio here, anything that I may have missed with the radar training, and then we can continue to showcase WeatherWise here for a little bit. If people want to see different features, and then I'll open it up for questions.
Can you hear me, Jonah?
Yes, I can hear you now.
Okay, I unmuted myself. You probably can't hear anybody because they're all muted.
Yeah. Yep. Yep, I can hear people now. So if Colin, you have anything you want to add, feel free. Otherwise, I will open it up to anyone to unmute themselves and ask questions. I would ask that. I think there's a raise your hand feature. I think, or you can just say that you have a question in chat so that we're not all unmuting at once. But if anyone has questions or things that they want to see in WeatherWise here, I am more than happy to take questions at this point. There is my contact information as well for folks who may need it. If you're with Kent County Skywarn, you can use that top email address. If you are not within Kent County Skywarn, feel free to shoot me an email on my West Michigan Weather account with that middle link there.
Hey, Jonah, can you hear me now?
Yes, I can hear you, Colin.
Excellent. Nothing to add. Fantastic presentation, sure. Very much appreciate your effort in putting it together and presenting it to us this evening. Anybody who is in attendance, you have the ability to unmute yourself whenever you desire to ask questions or give comments. You can also post them in the chat. I will be monitoring chat, as I'm sure Jonah now is also. So feel free to ask questions.
Well, hey, I just want to say thank you.
Yeah, of course. Who is that? I'm sorry.
This is Ron.
Ron? Yeah, very nice. Thank you. I'm happy to do it.
I'm with Montcalm County. That's where I started.
Okay.
I just switched over to Kent.
Gotcha. Okay. Yeah, I actually live in Montcalm County, so I work with Montcalm County sometimes as well.
Oh, okay.
Dick, you asked cost of each level. Again, you can get a lot of free features, including single site radar. WeatherWise Plus unlocks some more features. That's $6.99 a month or $69 a year. WeatherWise Pro unlocks all the features, satellite models, etc. And that is $160 a year. But again, I think Colin, you mentioned this earlier. This is quickly, in my opinion, becoming the leader in this market. It offers a lot of features, including 3D radar models, rapid refresh, fast scan, for much cheaper than a lot of the competitors.
Yes, I would definitely agree with that. I think the only radar software, in my personal opinion, which folks are free to agree or disagree with, is GR2 Analyst, which is the big brother of GR Level 3. And the only reason I say that it's a bit more higher end than even WeatherWise is it has more radar products and it's been around a long time. It's very well established. I think the volumetric, that is the 3D analysis of storms, is unmatched in GR2 Analyst. However, GR2 analysts also cost $250. So unless you're doing high-end radar analysis on Windows devices only, important clarification, it only works on Microsoft Windows, then by all means get WeatherWise. I use WeatherWise now on all my devices, so tablets, phones, computers, whether desktop or laptop. And again, I still use GR2 Analyst for some of the higher end, more minute radar analysis. But for 90% of what I need radar to show me, WeatherWise is fantastic. Definitely a better deal, I think, than Radar Scope or Radar Omega, both of which are perfectly competent programs. You don't necessarily have to switch if you have those, but I definitely agree. I think WeatherWise is pretty great.
It's just got a lot of customization, right? So, I mean, warnings, for example, if I go to, let's take tornado warnings, for example, you can change the colors like you can in GR level 2 or the GR products, which you cannot do on products like Radar Scope and Radar Omega. So that is very helpful. So you can kind of change things to your liking based on the alerts. You can change the color entirely. So if I want to make these fire warnings bright red, I can do so. If I want to make my tornado watches blue, I can do that if I so chose. And I'll continue to take questions. If you have those, don't feel like you have to type them in the chat. You can just go ahead and unmute yourself. Sure, we can all be civil, but if you feel more comfortable putting those in chat, feel free. While I wait for questions, I will just kind of showcase some of the different features that this has. So these are temperatures, temperature forecast from the GFS. We are anticipating seeing temperatures return to the 20s and 30s for the rest of the month, really. Maybe a couple of instances of some warmer temperatures, but overall below normal temperatures for the rest of March here in Michigan. So for those of you who have been enjoying the warmer weather like I have, that is no more. Can you save locations on WeatherWise? For example, marking the locations of friends and family on the map for future reference. Yes, you can. I will actually turn those on for you guys so you can see the locations that I have saved. Okay. And so I've got West Michigan Weather Headquarters, which is where I am at currently. I have my work. I have my girlfriend's house. I have West Michigan Weather East, which is where Owen lives. So for those of you who know who Owen is, the other co-founder of West Michigan Weather, got my other brother's house. So there are lots of different locations that you can add. And in fact, one of the new updates they did is they added in a home widget, so forecasts for each of those areas right on a widget. You can add this widget to the home screen on your mobile device. You can see the active alerts. You can see a forecast, outlooks. You get an Aurora forecast. You can enable things from the Ryan Hall YouTube channel. I take those with a grain of salt because, contrary to popular belief, Ryan Hall is not a meteorologist, but you can have all of the things that you would like. It's fully customizable for you to utilize. So I hope that answers that question. Turn those off. Is the GFS model the only available model? No, it is not. If I go back to models, there are several models in here. For global models, you have the GFS, the AI GFS, GraphCast GFS, the Euro Suite, Icon, and the Canadian as well. For ensembles, you have the National Weather Service blend of models. You have the GFS ensemble suite. For regional, you've got the NAM, RAP, RDPS, and the National Digital Forecast Database, which I actually like quite a bit to see total snowfall. So this is current total snowfall in the area. And you can, of course, see what those values are. A lot of the snow has disappeared across our area because of the warm weather we've had. And then, of course, we have some convective allowing models as well, including the HRRR, sub-hourly HRRR, the NAMNES, the RRFS, and the IHR-DPS. So there are a lot of models available. And having these models integrated with the platform that you use eliminates some of the need to have other subscriptions as well. So if you pay for Pivotal Weather, for example, which is a model website, or College of DuPage, or whatever model viewer site you use, some of the need for that can be eliminated by having this software. So if we want to see what the HRRR is thinking for temperatures over the next 48 hours, we can see that right here within our WeatherWise platform.
Now, Jonah, I'm curious.
Yes, go ahead. Sorry. Go ahead.
Yeah, I'm curious because I haven't actually looked at this feature myself yet. Does WeatherWise have the ability to do point soundings and show SQTs and hodographs like Pivotal Weather or College of DuPage does?
Sure, that's a good question. So that is one of the things that it does not do. It will give you a readout. Like if you hover over a certain area, it'll give you a readout of what that value is. So you don't have to discern that from your color scale. You can just hover over it and that'll give you the readout, but it does not do point soundings with log P and SQT charts. Nor does it do hodographs. So that is one downside. But again, this is a fairly new software. One of my favorite things about it is that RadarScope and Radar Omega, I feel, are very good platforms, but they don't get updated very often. And WeatherWise is updated at least once a month, sometimes multiple times a month, adding new features. I mean, like I said, they just added this new home feature. They added in some spotter network stuff. So there's just a lot of different things that you can do with WeatherWise. You can do storm tracks. So if we're looking at Centralville or Gloucester, there's a storm, we can actually draw a track out, apply the speed, and it will give you a readout of when certain areas are set to be impacted. Can it export model runs into GIFs? Do you mean like with like Pivotal Weather, you can create model loop GIFs? No, you could easily just screen record it though if you wanted to do that. Yeah, for sure, Brian. Ronald, do you have a little bit more clarification there about what you mean with flood? Are you talking about like flood warnings? And feel free to unmute yourself as well, Ron.
So I have a mouthful of chicken. But
You're
yeah,
good.
like flood warnings. I'm in Michigan, right off the Grand River.
Uh-huh. Yep, sure. So again, that home function, if you add your home location, and let's say we'll use my house for reference. If there were flood warnings, they would show up here. You can also display them on your map. So if I toggle alerts, we do have a flood warning over here in the St. John's and Ionia area.
Yeah, it looks like the Grand River.
Yep, yep. Grand River, just near Ionia there. So it displays those flood warnings. You can click on it, and it'll give you the issues, what the flood warning is for. You can go to impacts, and it'll tell you how many people are impacted. Public schools, transportation, dams. It gets pretty detailed. So there's another one here down here near Three Rivers. Of course, it was displaying the flood watch that we had last night, but here's a flood watch that we have in Ohio.
I know they just had that ice storm come through. Well, not real ice storm, but that thunderstorm come through last night.
Yep. Yep. So it shows all of those alerts as well. So, like for example, down here in Louisiana and Mississippi, we have an ongoing tornado watch in the yellow and severe thunderstorm warnings and tornado warnings in the red shading or in the red and orange boxes there.
Okay.
So it does show all of those alerts. Again, those alerts are customizable. So if you want them to be a different color, like if I want to make my tornado warnings, let me just steal this color so I can reset mine when I'm done here. But if I want to make mine, if I want to make my tornado warnings green, there's nothing that says I can't do that. So whatever, there's a lot of customization available. So
I still go on the National Weather Service, so I can do it right now. Cause I got an iPhone.
what was the question? I'm sorry, Ron.
I said I can still just go to the National Weather Service. That's all I can do right now.
Yep. Yep. So we've got the fire weather red flag warnings out here in the plains.
I got a question for you, Jonah.
Sure. Who is it?
Kevin.
Kevin. Yeah. What's up?
When you were showing changing the colors, is there an option to maybe change the border thickness or something for maybe if it's a PDS watch or warning?
Yes, there is. Let me fix this. Thank you, Jacob, for giving me this color code. So you can change your overall border thickness. Like if I want to change my tornado warnings to be maxed out, we can see how stark of a contrast that is now. But that applies to all of them. So the only thing you can do for the different intensity levels is change the colors. So that helps with contrast. And fortunately, there's not any like tornado warnings that are PDS or confirmed right now. But otherwise, if there were, I would showcase how some of that can be updated.
No, just what you said was just fine. Yeah.
Okay. Yep.
That's good. That's the information I was looking for. Thanks.
Yeah, of course. So just lots of different customization. That is really the culmination of this training. Again, I will be here as long as I need to answer questions. And of course, if you want to have a more private, if you have a more private question, you can always email me. Throw those back up on here really quickly. I am happy to respond to emails as well. There's a little shameless plug for my weather group as well. We work somewhat closely with Kent County Skywarn, um, just in terms of awareness and communication about severe weather setups. So we'll give people a few more minutes to give whatever questions, but it is 9 o'clock. So if people want to start filtering out and you don't have a question, that is totally fine as long as Colin doesn't have anything to add.
Once again, thank you very much, Jonah. Thank you to all who participated, whether from Kent County or from surrounding counties, as well as the good folks over at West Michigan Weather that are joining us tonight, either via Zoom or through one of the various live stream options. This will be recorded. In fact, it has been recorded, so we will post it on our YouTube channel here once the cloud recording is processed. Watch for that to come out in the next couple days or so. I'm sure Jonah also will distribute it via his West Michigan Weather social media, which is fantastic. So if you missed something, if you have questions after the fact, whether it be about Kent County Skywarn West Michigan weather or about the presentation, certainly feel free to contact Jonah. He can speak on behalf of all those groups. If you have a more general question for Kent County Skywarn, you're welcome to email our leadership team at skywarn@kcest.org, and I'll give that email in the chat. And then the Kent County Skywarn website is kcest.org/Skywarn. And finally, if you are not receiving Kent County Skywarn alerts, you can do so by signing up at spotterconnect.com. Once again, I will give links to all those locations in the chat. And also, one final thing. If you ever want to hear what good Skywarn radio discipline and reporting sounds like, listen to Jonah as he checks into a net. If you ever want to hear what running a good Skywarn net sounds like, you can attend our March 20th class, which is our second class in March. And Mr. Dick Seeley, one of the Deputy Skywarn coordinators, will be teaching that class. And he was the gentleman that you would have heard on the amateur radio repeaters last night. Very much appreciate him being on the air for us for 5 hours. So if you are interested in attending that class, feel free to let us know. Thanks, Jonah. That's all I've got, and back to you.
Of course, I did just quickly throw those links in here on the screen as well. Of course, we'll get those in the chat too. But
awesome, thank you.
Yeah, of course. No, I would like to say thank you to everyone for coming tonight. If this is something that you found helpful, please give it a share when the recordings eventually go live on YouTube. We'd really appreciate that, and it helps make people more weather aware, which is the whole goal of what we're doing here. So,
thank you, Jonah. Thank you, Colin.
Yeah, of course.
Yeah, Ryan. So our second class offered in March, taught by Dick Seeley, will be at the same time. So it will be a Zoom meeting at 7 p.m. going about 2 hours or so, and we will try and get that recorded as well. All right. Anybody have any final comments or questions for Jonah before we wrap things up here? All right. Hearing none, Jonah, anything else you wanted to cover before you close us out?
No, that is everything. Thanks again, Kent County Skywarn, for hosting this, and thanks again to everyone for attending this evening.
Likewise. And again, thank you to West Michigan Weather for the great material and for those of you who were able to join us this evening. So hope to see you next time on March 20th. And in the meantime, I hope you all have a wonderful evening and a wonderful rest of your week. We'll see you all later. Have a good night.
Thanks a lot, everybody.